Hey everybody, this is Mr. Munson. We are in Unit G.4, Triangle Relationships. This video covers Concept 4, G.4.4, Pythagorean Theorem Converse. This video is dedicated to Kyle in my third period class, who loves pizza, and especially pepperoni pizza. I think he is messed up when he says a pizza can have too much pepperoni, but that's just me. Take a look at that wonderful pizza pie. Mmm. I'm getting hungry just looking at it. Well, if you want to put me on pause and order a pizza, feel free to do that. Otherwise, let's get started.
All right, first of all, let's start with triangle classifications. When we classify triangles, we classify them by either their side information or their angle information. So three of the names that we have for triangles are over here on the left underneath the side information. They represent that I'm looking at the sides and recognizing something about the triangle according to its size. So for instance, scalene triangle is a triangle where all three sides are different numbers. None of the sides are congruent to each other. Isosceles is a triangle where you have two sides that are congruent, and equilateral is a triangle where all three sides are congruent. All right, over in the angle information, we have things like right, acute, obtuse, and equiangular. A right triangle is, of course, a triangle that has a right angle in it. Acute triangle is a triangle where all three angles are acute or smaller than 90. An obtuse triangle is a triangle where one angle, and there can only be one angle is obtuse. And then finally, equiangular triangle is basically a triangle where all three angles are congruent to each other. This forces the three angles to be all 60-degree angles. Okay, let's start our notes here, and we have G.4.4 classifying triangles using the Pythagorean theorem converse. Now we know what converse is, but we'll kind of just review that real quick. Okay, so two things first. We need to remember the Pythagorean theorem. All right, so the second thing that I need you to know is what a converse statement is. And if you remember, a converse is the one with the shoes reference that I always make. So if I have a P then Q statement like, if it's raining, then the ground is wet, the converse of the statement is, if the ground is wet, then it's raining. Now we have the names of the triangles already covered in the previous section of notes. And so I'm looking at these three triangles and I'm saying, let's classify them. So each one of these we classify by giving it a side name and then an angle name, okay? So we're classifying it by two different categories. That's for each one of these. Now, if you look at the first one, I don't know all the angles, and before I can pull from this list, I need to know something about all the angles. Now, if the two angles are 45s, then that adds up to 90. By subtracting that from 180, I can find that this angle has to be 90. Now, from the angle category, I now have enough information to say it's a right triangle. Okay, now let's think about this. I have two angles that are congruent. As we just learned in a previous concept, that if we have two angles that are congruent, then the opposite sides are congruent. Remember, if we're ordering the sides, across from the largest angle is the largest side. If we have a tie like this, we have two angles that are both 45. That means that there's a tie for the sides being the same. So from that information, I conclude that the side across from this 45 and the side across from this 45 have to be the same size sides. So from the category of names of side information, that's an isosceles triangle. All right, now do something similar. See if you can think this through for the other two remaining problems. Put me on pause and then come back and check your work. Okay, so here I have a 25, a 30, and a 125, 125-degree angle. And so just from the category of angles, what I know is that that 125 allows me now to call this triangle an obtuse triangle. Now, looking at those angles, I could certainly order them from smallest to largest, which means that all the sides would be able to order smallest to largest. There's no ties, so there's nothing like the isosceles. It means that all the sides have to be different. If all the angles inside are different, then all the sides on the outside must be different. And that, from our category of names, is called a scalene triangle. All right, now let's take a look at this last one. If you haven't gotten here yet, see if you can put me on pause and think this through. Well, certainly through the triangle sum theorem, I know that this angle here has to be 60 degrees. All three of the angles have to add up to 180. And since 60 and 60 have been already used on these two, that leaves 120 already spent. That leaves me 60 to be left over here. Well, I know from the category of angle names over here, that's an equiangular triangle. Now, here's the interesting thing. There's a tie in all the angles. And what I know from that, then, there must be a tie in all the sides. If all the angles are the same, then all the sides must be the same. So from that logic, I'm going to conclude that it's equilateral as well. Now let's take a look at the converse of the Pythagorean theorem. So to begin with, the Pythagorean theorem is basically this. If I have a right triangle, then a squared plus b squared must equal c squared. But if you look at this, I have the converse saying the a squared part first. If a squared plus b squared equals c squared, if I take the three sides and plug them into the Pythagorean theorem, and it's true the left side equals the right side, then the triangle must be a right triangle. So I get to conclude that something's a right triangle. In the Pythagorean theorem, I have to start off with the fact it's a right triangle before I can use the Pythagorean theorem. So this is the converse of the Pythagorean theorem. So how would I use that? Let's take a look at these two problems over here. Now, first of all, I really don't need to decide anything with this one, right? If this side's 4, this side's 4, and this side's 4, then all the three sides must be congruent. And that tells me that it's not a right triangle at all. It means that all the sides are the same. That means all the angles are the same. So that would mean that all the angles are the same. So this is actually an equiangular and an equilateral triangle. But now let's take a look at this one, 3, 5, and 4. So what this is saying is if I take these numbers and plug them into the Pythagorean theorem and it's true the left side equals the right side, then I get to conclude it's a right triangle. So I have some triangle drawn, right? It's a 3, 4, 5 triangle. Now I'm going to plug them into the Pythagorean theorem. Now, very important, you need to notice I did not stick the 5 in here. I didn't put them in order. I put the 5 over on this side because 5 is the largest side. If there's any hope that this is a right triangle, the largest side must be on the hypotenuse side. Okay, let's check to see if this is true. I'm going to put a question mark here over the equal sign. And I think I should encourage you to do the same so we know we're not actually solving anything. We're just checking, does this work? So I have 9 plus 16 equals 25 with a question mark. And then we have 25 equals 25. And that's a true statement. That means that this actually is a right triangle. I didn't draw that very good. It's like this. Here's my right triangle, 3, 4, and then 5 has to be over on the C side. All right. I want you to go ahead and put me on pause and check this one out and see if this is a Pythagorean theorem. If this is a right triangle. Put me on pause, come back and check your work. Well, I found that when I plugged in the pieces in the correct places, this did not work. Remember that 6 has to go over here. The largest side will always go in the Pythagorean theorem over on that side. So 25 does not equal 36 in my world, and therefore what I just concluded is these pieces right here, if I was to take those and put them together and form a triangle, then yes, they would form a triangle, but not a right triangle. Okay, so if it's not a right triangle, then it's got to either be an acute triangle or an obtuse triangle. Those are our only other opportunities. Now in the category of angle names for triangles, classifying triangles by their angle names, we have acute, obtuse, right, and then also equiangular. Now I know it's not equiangular because all the sides are not the same. All right, let's move on. Okay, Looking at these three things, I call this the three bears theorem. That's totally made up. This is something that I did. What ends up happening is we have several different scenarios that can happen. When we're processing the Pythagorean theorem converse, we come up with times where the two things are not equal. Well, you have a choice. It's either acute or obtuse, and depending on what the situation is, it will tell us if it's acute or obtuse. Okay? So if I plug the numbers in and I find out that the C side is too big to be equal to the a squared plus b squared, in other words, the left side is too small, right? If the C side is too big to be equal to a squared plus b squared, then it must be an obtuse triangle. And if it turns out that the C side, when I square it and compare it to the a squared plus b squared, it's too small to be equal to a squared plus b squared, then it's an acute triangle. And then finally, if I find out that a squared plus b squared equals c squared, then it's right. Now, I hope that you understand why I call it the three bears theorem. It's either too big, too small, or just right. All right, let's just do a couple of these problems and then head on over to doing our summary and doing our do it problems. Okay, so let's classify this triangle. What I'm going to do is I'm going to find out if it's a right triangle. So I'm going to stick it into the Pythagorean theorem converse. Again, I'm making sure that I stick the largest side over on the right-hand side. I'm going to put a question mark there because I don't know if this is equal. 25 plus 36 equals 49. Now I'm going to add 25 and 36, and I'm going to end up with 61, which is not equal to 49. Matter of fact, 61 is bigger than 49. Okay, well, according to the three bears theorem, the side that I thought was a hypotenuse is just too small to be equal to 61. It's too small. And so in other words, I know from the three bear theorem that this is not a right triangle, but an acute triangle. All right, put me on pause, and you go check yourself with this one. See if you can discover, using the three bears theorem, triangle converse, or the Pythagorean theorem converse, the three bears theorem as well, to figure out, is it an acute, is it right, or is it obtuse? Put me on pause. All right, there you have it. After doing the Pythagorean theorem converse, I find out that 100 is less than 121. And in other words, the thing I thought I was hoping to be my hypotenuse is too big to be equal to a squared plus b squared. In other words, this is not a right triangle, but an obtuse triangle. Now, if we wanted to go back to both these problems and classify them by their side information, I could do that as well. See, if I looked at that 5, 6, 7 triangle over here to the right, to the left, I know that all the sides are different. That means it's a scalene triangle. And the same thing ends up being true for this one over here, scalene. Now, if two of the sides had been the same, I would say, hey, this is an isosceles triangle. And if I saw that all three sides are the same, then I would say it's equilateral. I would not even walk into the Pythagorean theorem converse. If all the sides were the same, I wouldn't even bother plugging it in. I know that it's not a right triangle. It's not an obtuse triangle. It's not an obtuse triangle. It'd have to be an equiangular equilateral triangle. All right, well, there you have it. Here is your 5 do-it problems. Actually, number 5 is a bonus, okay? So you're going to do that on a separate piece of paper and turn that in if you choose to do that, okay? All right, classify each triangle. Remember, we need to make sure we classify them by the side and the angle, so just pull from that list we had at the very beginning. Make sure that for 1, 2, and 3, and 4 as well, your work is clear and neat and understandable. So I should see the Pythagorean theorem converse unfolding with a question mark over the equal sign and so on. Now 4 is not a Pythagorean theorem converse. That's a review problem of the Pythagorean theorem. So see if you can use the Pythagorean theorem to find x in this case. All right, that's it. See you next time.